Embark on a breathtaking cosmic odyssey as we delve into the revelations brought forth by the James Webb Space Telescope. With a focus on our radiant sun, this extraordinary telescope takes us on a journey back in time, revealing the cosmic cradle that embraced our sun shortly after its celestial birth. Transcending the capabilities of its predecessor, the Hubble, the James Webb Space Telescope, invites us to witness the universe in unprecedented detail. Each image captured by this technological marvel is a stroke of genius that reshapes our comprehension of the cosmos. As astronomers, space enthusiasts, and amateur stargazers eagerly anticipate every new snapshot, Universal Narratives becomes the portal through which the wonders of the universe unfold. Join us in collective admiration as we traverse the cosmic gallery, unlocking the secrets of the universe with every click of the telescope's shutter. This is not just a journey through space, it's a journey through time, exploring the celestial wonders that have shaped our existence. This remarkable image presents us with the Whirlpool Galaxy, also known as Messier 51 or NGC 5194, located at a distance of 23.1 million light-years, characterized by its majestic spiral arms. Supernova 2022a, within the spiral galaxy pair ARP 299, fascinates with its unique color show. Even the Ring Nebula, a fond companion of the cosmos, shines with new intensity thanks to Webb's technology and James Webb's filters. The telescope is not just offering fascinating images of the immense size of the universe. We can now examine formations and many other discoveries in a way never before experienced in human history. Now, observations of a very special star give us the first taste of what the sun looked like in its early stages of birth. This is not how stars form. Have you ever wondered how stars actually form? In theory, it begins with collections of gas and dust that are moved by forces such as the pressure from other stars or the impact of supernova explosions. Rotating faster and faster, the cloud is attracted by its gravity until it becomes denser and denser. The temperature and pressure at the center then continue to increase and boil until the nuclear fusion process finally begins. Voila, a star is born. The fusion process then continues for millions or billions of years. Our sun went through this process about 4.5 billion years ago and is still shining today. The elements for fusion still primarily come from the clouds from which the sun was born. Everything we know about the birth of stars was initially theoretical. Scientists reconstructed this process from fundamental physics and derived the rest simply from Einstein's theory of relativity. Only much later did they see the first young stars in the universe and were able to confirm their theory through observations. But what did the young sun look like? To understand this, we must look at Herbig-Haro 211. The James Webb Space Telescope has provided us with extraordinary images of this star, giving us a unique understanding of what the sun looked like when it was born. Herbig-Haro 211 or HH 211 shows a very young star at the center and bipolar material jets to the left and right. Herbig-Haro objects are space phenomena associated with the formation of young stars and star-forming regions. They are named in honor of astronomers George Herbig and Guillermo Haro, two researchers who discovered these wonderful and fascinating objects almost simultaneously in the 1950s. Imagine what it would be like if star formation actually took place in interstellar space at supersonic speeds. Herbig-Haro objects are actually bright spots around young stars. They form when young stars release material into interstellar space, driven by the speed of the star's movement. The protostar in this image shows what our sun was like 4.5 billion years ago, when it was only tens of thousands of years old and only 8% of its current mass. Young stars like this initially absorb more mass from their surrounding environment and grow significantly in the early stages of their lives. However, in later stages, the star contracts again. Our sun also loses mass, but to a much lesser extent. The sun's mass loss is mainly due to the solar wind, a stream of charged particles blown into space from the surface of the sun. Experts estimate that the sun loses about 4.5 million tons of mass per second on average. At first glance, it may seem large, but it is still tiny compared to the total mass of the sun. As the sun continues to grow, its annual mass loss over the course of its life translates to only minimal changes in its total mass. and this will continue to be the case for a long time. Our star has just passed the halfway point of its life. Why do young stars emit jets? The HH-21 jets are energetic flows of material expelled from young stars that shine in space with fantastic colors. These jets, in fact, are primarily composed of gas and dust and travel through space at extremely high speeds. These luminous flows are associated with almost all Herbig-Haro objects and play a prominent role in studying the mysteries of star formation and the interaction of young stars with their environment. The HH-21 jets are bipolar, meaning they travel in opposite directions, extending in space along the axis of rotation of the young star and traveling upwards and downwards. These jets are typically characterized by extremely high velocities, often reaching hundreds of kilometers per second. This high velocity is the result of the enormous energy released by the interaction of matter in the protostar. When the jets collide with the surrounding interstellar medium, they create impact fronts with higher density and temperature. In these impact fronts, the jet material encounters interstellar gas and dust, once again offering a perfectly captured colorful spectacle by James Webb, thanks to the exceptional intensity of light that the telescope can capture and display. Herbig-Haro objects like HH-21 can now be studied in even more detail thanks to the light that reveals many details about the processes surrounding this object, located approximately 1,000 light-years away. The light waves reveal details about the elements involved, the density of dust and gas accumulations, and the velocities surrounding the object. After analyzing the data from HH-211, scientists have discovered that the jets are rich in molecules including carbon monoxide, silicon oxide, and molecular hydrogen. Other researchers believe that HH-211 is an ideal study object because it is one of the youngest stars and the closest to the material expulsion. Thanks to the James Webb Space Telescope, we can now follow the birth of stars with greater precision than ever before. But what were the first stars like? Would you believe me if I told you that we had no idea how the first stars actually formed in space? It seems crazy, but it's true. No researcher has ever seen or analyzed such a star in detail. But why is that? Well, observing the primordial phase of the universe is not easy. The light that reaches us is significantly stretched due to the expansion of space and shifts towards the red end of the spectrum. The oldest light signals identified so far by James Webb are dark red and diffuse. In fact, we still don't know if they are actually galaxies and how we can recognize the individual stars within these formations. It would seem almost impossible if it weren't for a fortunate coincidence. One of the oldest single stars ever discovered is WDHL 0137LS, which scientists also call Earendel, or the morning star. It stood out only because it was significantly magnified by the gravitational lensing effect. This effect occurs whenever a very massive object, such as a galaxy or even a black hole, causes a distortion of spacetime. The curvature acts like a convex lens and sometimes magnifies background objects so much that individual stars become visible that we would normally never be able to recognize because they are simply too small in the vastness of space. So the discovery of Earendel was truly a stroke of luck. Another object that is probably one of the oldest single stars is SMSJ 31300 36 670,839.3 or SM0313 for short. Researchers have calculated that the star could be 13.6 billion years old. This indicates that the star is one of the first-generation stars. Researchers call these stars, which have so far been purely hypothetical, binary populations. And the prototype stars may have formed from primordial clouds of gas and dust left over from the Big Bang. Due to the changing forces in the universe, these clouds start to vibrate, condense under their own weight, and begin the fusion process. These first stars were likely much more massive than stars today. According to previous hypotheses, the decisive factor in the formation of very large first stars was the lack of heavy elements. This meant that the first stars could only use light elements, which had a profound impact on the properties of the three stars. These first stars were extremely massive, with some estimated to be hundreds or thousands of times more massive than the Sun. Due to their enormous mass and almost pure composition of hydrogen and helium, they generate intense radiation and temperatures of tens of thousands of degrees Celsius. Because of these extreme conditions, their lifespan is short, only a few 100,000 years. Only when these stars exploded did heavy elements begin to circulate, laying the groundwork for the formation of new types of stars and eventually stars like our Sun. However, so far, all of these scenarios are purely theoretical. Scientists hope to see the full force of the population reach the 3 stars. The existence of SM0313 has not been 100% confirmed. In a nutshell, this means that neither the age of the star nor its composition can be unequivocally determined. A structure used by scientists to search for the oldest single stars in the universe was destroyed in a fire in 2003. Now the astronomical community eagerly awaits the day when James Webb will attempt to find this extremely distant star again. The formation of the first stars in the universe is a fascinating topic that will keep us busy for a long time. James Webb has shown that the first galaxies appeared much different from what researchers imagined, and we look forward to seeing what surprises this special telescope will reveal.